Hello everyone, welcome to Simplify CAIE. Today we are going to be solving Chemistry Paper 4 0620 Feb March 2025. Let's begin. Question number 1. Using numbers only, state the percentage of oxygen in clean dry air. Memorize this pie chart everyone. This is an estimate percentage of all the gases in clean dry air. So it is 72% of nitrogen, 21% of oxygen, and 1% carbon dioxide and the noble gases. So for percentage of oxygen, it is going to be 21%. Typical operating temperature in degrees Celsius for the Haber's process. Haber process is the manufacture of ammonia, and the typical operating temperature would be 450 degrees Celsius and the pressure 200 atmospheric, and the catalyst was iron. Number of atoms in diatomic molecule. So diatomic molecule means two atoms. Maximum number of electrons in the second electron shell of an atom. So the first shell consists of two electrons, whereas the second electron shell and onwards consist of eight electrons. Number of hydrogen atoms in an alkane with seven carbon atoms. So what's the general formula for alkanes? The general formula is CnH2n plus 2, where n is the number of carbon atoms. There are 7 carbon atoms. So C7H 2 times 7 would be 14 plus 2 would be 16. So number of hydrogen atoms would be 16. Number of particles in 1 mole in standard form. Basically they are asking for Avogadro's constant, which is 6.02 raised to power 23. Next up, question number 2. The question is all about ionic compounds. State what is meant by the term ionic bond. If you refer to your syllabus 2.4 ions and ionic bonds, pointer number 2, state that the ionic bond is strong electrostatic attraction between oppositely charged ions. You must write the term electrostatic attraction between oppositely charged ions. These two terms are compulsory in this definition. Potassium sulfide is an ionic compound. Complete the dot and cross diagram of the ions in potassium sulfide. Okay, so potassium sulfide has the formula K2S. Using the crisscross method, we can determine the charges on respective ions. Potassium plus 1, sulfur minus 2. So these are our ions. So we have determined the charges. So now that we have determined the charges, now we can look into the periodic table, and as sulfur is in period number 3, right? So it will have 3 electron shells. So let's draw the third electron shell over here. And as it is in group number 6, as it is in group number 6, it will be having 6 valence electrons. So 5 and over here 6, right? And as there is a minus 2 charge, that means it has gained 2 electrons from potassium. So now we are going to represent with a dot the electron that has been gained by sulfur. And a common mistake in this paper was that many students forgot to draw the shell of potassium ion, as potassium is in fourth period, right? So potassium atom is going to be having 4 electron shells. As now it has lost one of its electron, the outermost electron, now it will be having same electronic configuration as argon, right? So it will be having 3 electron shells, and the outer shell is going to be full, just like that. Let's move on. Ionic compounds form giant ionic lattice. Figure 2.2 shows part of giant ionic lattice structure of sodium chloride, NaCl. Complete the diagram. Use positive for sodium ions and negative for chloride ions. One chloride ion has been completed for you. So for this, just remember that negative attracts to positive, right? And the ionic, and we have just written the definition of ionic bond. So there will be attraction between oppositely charged ions, right? So over here it is negative. So I'm going to make a positive over here, and then a positive over here, and then as this is positive, below this is positive, over here it's going to be negative, and the same over here, negative bonds with positive, and this negative bonds to positive, then this, and then this. So that's that. State the name given to any positive ion. Cations. Ionic compounds can be decomposed by passage of an electrical current using inert electrons. State the name of this process. Electrolysis. What's the definition of electrolysis? It is the breakdown of ionic compounds in molten or aqueous state through passage of an electrical current. Moving on to part number 2. Write the ionic half equation for the reaction which takes place at the anode when molten potassium bromide is decomposed by passage of an electrical current. As this is molten potassium bromide, the only ions present would be potassium ion and the bromide ion. And as they're asking for the half equation at anode, an anion would be attracted because anode is a positive electrode. So obviously a negative species will be attracted towards it. Right, and you can remember it by using the mnemonic panic, that the positive is anode and negative is cathode. So bromide will be attracted towards the anode. And what occurs at anode? Oxidation occurs. How can you remember this as well? You can remember it by using this mnemonic anox, anox. Or you can simply remember the other way around, red cat. Red cat basically means reduction occurs at cathode. So you can remember these mnemonics to make electrolysis and your life easier. Bromide is going to be attracted to anode and oxidation occurs. What is oxidation? Remember it by using oil rig. Oxidation is loss of electrons. This L stands for loss and reduction is gain of electrons. Now to balance it, 2 with bromide ion and 2 electrons. Moving on, name the products. Name the products and state the observations. Okay, at negative and positive electrodes. So negative electrode is your cathode and the positive electrode is your anode. Right. When dilute aqueous potassium bromide is decomposed by passage of an electrical current. Okay. So product at the negative electrode, which is your cathode. So at cathode, cations will be attracted, right? So cations will be attracted. As now it is aqueous potassium bromide, the ions present would be potassium, bromide ion, and the ions of water as well. So hydrogen ion and hydroxide ion as well. So these four ions will be present in your electrolyte. So now the question is, which of the cation will be attracted to cathode? As hydrogen is lower in the reactivity series than potassium, so hydrogen is going to be discharged more readily. So the product at negative electrode would be hydrogen gas. As hydrogen will get reduced to form hydrogen gas, something like this, right? Now, observation at negative electrode, as a gas is being produced, so the observation would be bubbles. Now, for the products at positive electrode, now they are asking for the positive electrode, which is your anode. So now we have to choose between the anions. How can we choose between the anions? by looking at the concentration of the electrolyte. If it is dilute, so more water is present, right? So more hydroxide ions will be present. Cause of that, hydroxide will be discharged more readily. And please memorize this equation. Hydroxide discharges and it gets oxidized as at anode oxidation occurs. So hydroxide gets oxidized to form oxygen plus water plus electrons, right? So 4 with here, 4 over here, and 2 over here. So this is the equation. Please memorize it. So the products would be oxygen and water. And as you can see, I'm naming the products rather than writing its symbol, right? Because they've asked us to name the products in the question. Observations at the positive electrode. Again, a gas is being produced, oxygen gas is produced, so the observation would be bubbles. Next up, question number 3. The halogens are a group of elements in the periodic table. Chlorine is member of this group. State the group number of the halogens. As we look into the periodic table, chlorine is part of the group 7, or we can say group 17. So we'll just write it 7. State how many halogens there are in this group. So let's count. 1, 2, 3, 4, 5, and 6. So 6 halogens. Suggest the identity of the halogen which has the highest density. Okay, so down the group for group 17, down the group, the density increases. So as density increases down the group, the heaviest one would be tennessine. So TS, or you can simply write the name, is most reactive. So as we know, down the group, the reactivity decreases. So the most reactive halogen would be the one which is at top, which is fluorine, right? So we can just simply write fluorine over here. State the name of the negative ions, anions formed by halogens. They are called halides. For example, the ion formed by bromine is called bromide. The one formed by chlorine, chloride. State how many occupied electron shells there are in bromine atom. Okay, let's look into the periodic table. As we know that the bromine is in period number 4, right? So that is why it will be having 4 shells, as the period number decides the number of shells, right? So moving on, name the noble gas, basically group number 8, okay, which has the same electronic configuration as bromide ion. So it's bromide ion. Okay, so let's look into here. As bromine atom has 35 protons, so it will be also having 35 electrons, right? If it was bromide, then the electrons would be 36, right? And krypton has 36 protons and 36 electrons. So the electronic configuration becomes equal to krypton's electronic configuration. So bromide ion has the same electronic configuration as krypton. And again, they have said name the noble gas. So that's why I'm naming it rather than writing its symbol. Aqueous fluorine, okay, reacts with aqueous potassium iodide. One of the products formed is iodine. Complete and balance the ionic equation for the reaction between chloride and iodide ions. State symbols are not required. Okay. So as I said earlier, that down the group, the reactivity decreases, right? So the reactivity decreases down the group. And for halogens, we need to remember this displacement reaction. A more reactive halogen will displace a lesser reactive halogen. As chlorine is above, as chlorine is above iodine, so it can displace iodine from its compound. So basically, Cl2 reacts with potassium iodide to form KCl plus iodine. Now we balance it, 2 over here, 2 over here. So this is balanced now. And if we write the ionic equation for this, then the potassium ions, two potassium ions will get cancelled out as they both are spectator ions, right? So 2 over here with iodide and 2 over here with chloride ion. Explain why this reaction is defined as a redox reaction. What does redox reaction mean? Redox reaction means that reduction and oxidation occurs simultaneously in the reaction. So give your answer in terms of electron transfer. So now you need to remember this oil rig. So chlorine gained an electron to become chloride ion. Iodide ion lost its electron to become iodine, right? So we can simply say that Cl2 gains an electron to become Cl minus, therefore reduction. Then iodide loses electron to become iodine, therefore oxidation takes place. And then you can simply say redox reaction is a reaction where oxidation and reduction takes place simultaneously. But this is enough. Next up, give the color and state of iodine at room temperature and pressure. Okay, you can screenshot this table and memorize these colors because they can ask you for any one of this. And for iodine, remember, for iodine, if it is heated, it will be having purple vapors. Okay, if heated. So remember this for iodine. But for now, they have said at room temperature. So the color would be gray black and the state would be solid.